In the previous lectures, we have studied about motion. Okay, the study of motion was termed as kinematics. Termed as kinematics. We studied about V, U, A, T, S. Today, we are going to study the cause of the motion. The cause of the motion over here is a force. Whenever I am dealing with force, I am dealing with the cause of motion. Now, we are studying about the cause of motion, and I'll deal with some topics which are very, very important. Firstly, definition of force. Secondly, I'll deal with the term momentum, P bar. Third one, I'll deal with all the laws of motion, Newton's laws of motion, first law, second law, third law. Then I'll be dealing with something called as impulse. Okay, beta? We're dealing with these quantities today. So define force. Can I say force is a push or a pull that changes or tries to change firstly state of rest, state of motion, state of direction of a body. So, force is a push or a pull that changes or tries to change the state of rest. Means what? If there is a ball and I apply a force, it will move. Can I say the state of rest has changed? But if there is a big rock, I try to move, will it move? So over here the force is trying to change the state of rest, but it's not happening because the force is not enough. Getting it? Second concept. Force is a push or a pull that changes or tries to change the state of motion. A ball was coming, I catch it. I changed the state of motion and it came to rest. But if a rock comes rolling down, I try to stop it, I will not be able to stop. Understand? So I am trying to change, but the state of motion doesn't change. Third, force is a push or a pull that changes or tries to change the state of direction. You take a stone and tie it to a string and you whirl it around the circle. Can I say that force in the string is going to change the direction of the stone continuously? So it is changing or trying to change the state of direction. This is what the force does. Is a push or a pull that changes the state of rest or tries to change the state of rest or state of motion or state of direction. Are you all understanding? Okay. On the basis of this, we will define more terms. The first term which I want to define is momentum. P bar. What is momentum defined as? Momentum is defined as the quantity of motion packed inside a body. Quantity of motion packed inside a body. So we are discussing momentum is quantity of motion packed in a body. When I talk about motion, there's mass and there is velocity. And mass and velocity make a term called as momentum. Sir, why does it depend on mass and why does it depend on velocity? Because you know kinetic energy also depends on mass and velocity. What is the formula for kinetic energy? What is the formula for kinetic energy? Half mv square. I'll explain why is the mass and the velocity so important. Suppose I was going in a stroll in the morning, half sleeping, okay, I was walking on the road, half sleeping. And a cycle wala came fast and it hit me with a high speed. The cycle wala came with high speed and hit me. Will I get more hurt, like a damage will be done? No. Small hurt here, scratches will be there and fine, no problem. You know, it was going with high speed. But then also it hit me. The mass of the cycle was so small that the damage caused to me was minimum. Next day morning, again I was sleeping. Okay. A truck wala was taking reverse with a small speed, not so high speed, with a very small speed, maybe 1 meter per second, and the truck hit me. Now the damage will be more. That means the motion packed inside the body depends on mass. Greater is the mass, greater is the motion packed inside. First concept. Second concept. I want to shoot this person. Okay. So I'll remove the gun and shoot him. The damage is done. Pay attention over here. The damage is done. Why? Because the velocity of the bullet was very high and it pierced his body. Motion depends on velocity. Second case. I want to shoot him again. Or then we'll leave. Shoot him. So I take a bullet and throw it at him. I take a bullet and throw it at him. Will he get hurt or what? No. The same bullet, here the damage was done because of the high speed. Here the damage is not done because of low speed. So can I say the quantity of motion packed inside the body, which is momentum, is defined as the product of mass and its velocity. Is P bar, mass is m, velocity is v bar. Momentum is so important that all definitions are made according to momentum. Is the product of mass and its velocity, and the direction is same as the direction of velocity beta. And what will be the unit of this? kg meter per second, and the dimensions will become m1, l1, t minus 1. You don't worry about that thing if the chapter is not done. Okay. So this is momentum, the motion which is packed inside the body. You getting it? On the basis of this momentum definition, we will define all the 3 laws in physics of motion. First law. न्यूटन्स लॉज ऑफ मोशन का फर्स्ट लॉ, एवरी बॉडी कंटिन्यूज टू बी इन अ state of rest or uniform motion unless unbalanced external force acts on it. Everybody continues to stay in a state of rest or uniform motion unless acted by an unbalanced external force. Now it is very much necessary to dissect this topic. They have told you a lot of things inside. First law is telling you every body, not only in the earth, anywhere you go, it is a law. Law मतलब कहीं पर भी चलेगा. Jupiter, Mars, Venus, Pluto. It is a law which is universally applicable. Everybody will continue to be in a state of rest. Means a body who is at rest will remain at rest. A body in uniform motion will remain in motion unless and until an unbalanced external force comes and acts on it, and it will change the state of rest or uniform motion. Means what? Suppose there is a body which is at rest. This is a body which velocity is beta what? 0. Or a body which is moving at a constant velocity. It will not change its condition unless and until an unbalanced external force will come and act on it. Means what? If the book is lying over here on the table, it will ever and ever lie on this table unless someone comes and picks it up. So simple to understand. A body moving with a constant velocity will keep on moving with that velocity only unless an unbalanced external force acts on it. But in nature you feel that this stops after some time. A football rolling on the ground stops after some time. Why? Because there is some unbalanced invisible force called as friction which is acting on this body. But if there would be no friction, it will continue to move with the same velocity till infinity. Suppose I throw this in space where there is no gravity, no friction, nothing, it will keep on moving. If I give it a velocity and leave it till infinity, it will keep on moving because it is obeying first law of motion. Okay. Unless an unbalanced external force acts on it. Now my questions to you all. I am standing over here. Am I at rest? Am I at rest right now? Yes. Is any force acting on my body? Yes, the force acting on my body is the gravitational force. Is it balanced or unbalanced? By whom? By the reaction by the floor. There is action, that is my weight. There is a reaction by the floor, and that action, okay, that weight will cancel the normal reaction, and the net force acting on my body will become equal to 0. Therefore, if I am at rest, I can say the net force acting on my body is how much beta? 0. ऐसा नहीं है कि force ही नहीं होगा. Force is there. Force is there. Force is there. But they will balance out. He is speaking about unbalanced force. Unbalanced force means whose magnitude is greater in one direction. यहाँ पे the magnitude of, suppose I am applying 100 Newton. So he is also applying 100 Newton. अगर ऐसे होता, suppose if I apply 100 Newton and he applies 200 Newton, I will go up by 100 Newton net force. But यहाँ पे ऐसा नहीं होगा. Unbalanced external force Very important. I'm going to give you another example. Suppose we go for a picnic and you are there inside the bus and the bus ka petrol gets over. Scenario, the petrol, the fuel which is there is over. Now the driver tells everyone, get down from the bus and push the bus to the petrol pump so that I can fill the petrol and take all. Okay? I tell you all one thing, no, do one thing, students, sit inside the bus and push the seat in front of you. Okay, remain seated where you all are and just push the seat in front of you. New idea? Okay, will the bus move? No, it will not move. Won't move. Why? Yes, correct. Tell me.
The seat is fixed, so you try to balance your force.
Okay, anyone else? Yes.
It will be internal force, right?
Okay, anyone else? Fine. So, two of them are giving correct answers only. She told me that if you apply F, the front seat will also push you with F. If I am applying 100 Newton, he is also giving 100 Newton. So they will cancel out each other. It is not unbalanced, it is balanced. And he told me, bhai, uska naam hi internal force hai because it is inside the system. Both of them are correct. Okay. But technically, if you see that if I am applying 10, he is also applying 10. So rather than being unbalanced, it is balanced. Chahe andar ho ke bahar ho, it is balanced. Okay, so you all tell me, no sir, nothing is happening, you need to come out. Now when I need to come out, I push the bus with my hands. Right? I push the bus with my hands. Can anyone tell me why does the bus move in that condition? I push the bus now with my hand. Now the bus move.
It's free to move. No, the net force is
Unbalanced. There's nothing stopping it.
The bus is not. There's no one to push the bus from the opposite direction.
Okay.
The bus is in neutral, so the tires will move. And
The bus is in a state of rest. The more the force you apply.
See, I want. Yes, is correct. Everyone is giving some answers. You need not laugh anything. Please pay attention. We are here to learn. That is most important motive. Okay. Little answers I want from everyone. I will tell you the answers, no use. You need to start. Now what is happening over here? Please pay attention. Everyone has given correct answers. Yes. According to their thinking, according to the frame of thinking. No problem. When you push the bus, your hands are on the bus. Where is your feet? Ground. Now listen what happens. I push the bus with 100 Newton. The bus also pushes me with what? 100 Newton. My feet is pushing the ground with what Newton? 100 Newton. And the ground is pushing me with what? 100 Newton. And that 100 Newton is going on to the bus which is unbalanced. Again understand. If I push the bus with F, I am going back also with F. But there is someone who is giving me that F. Who is that? Ground. The ground is giving me, the floor is giving me F. And that F only I am giving it to the bus which is unbalanced. So actually you are borrowing the force from the ground and giving it to the bus by pushing the ground in the backward direction. Are you understanding? By pushing the ground in the backward direction, you are borrowing the force and giving it to the bus. All push and pull happen the same way. You borrow it from the ground and give it to some object. I'll tell you one thing. I want to push the bus, correct? But I'll tell you that stand on roller skates and push the bus. Imagine yourself standing on roller skates and pushing the bus. What will happen? You will fall backwards. Are you imagining what is happening? What 100 Newton you give? The ground couldn't give you 100 Newton. And it pushed you back and you will fall down. Or you are standing on banana scales and pushing. You will go backward, you will slip backwards, right? You are borrowing the force from where? From the ground. Understand? Okay. A wrestler comes and tells me, sir, I want to fight with you. I tell him, bhai, I know only physics, I can't fight with you. You are a champion. No, I want to fight with you. ठीक है. I'll tell him, watch one condition. One condition. You fight with me when you are there on roller skates. You wear roller skates and you fight with me. He will not be able to borrow any force from the ground. One push, he is gone. Understand? Any big wrestler, anything, they all borrow the force from where? From the ground. Nothing else. They can't do anything. If the ground doesn't give them force, finished. Okay. Because whatever force you have, you are applying on the ground and taking it from there. Otherwise, nothing. This explains what? First law. And this explains unbalanced external force. You can see it is unbalanced because it is borrowed from the ground. There is no one to balance it. External force because it is out of the system. This law is also termed in physics as, what is it termed as better? Law of inertia. Very important word. Inertia. What do you mean by the word inertia? What do you mean by inertia?
So after coming to rest, it will continue to be in its motion due to mass for a particular period of time.
The tendency of an object to remain in its state of motion or rest.
Correct. Anyone else? ठीक है. Anyone else? ठीक है. In basic language, the ability to resist the change. I am at rest, I like to be at rest. I am in uniform motion, I like to be at uniform motion. Unless an unbalanced external force acts on me, you don't try to change me. If you try to change me, I will oppose you. This inertia means resistance to change. इधर ध्यान देना बेटा, please, very important. It doesn't want to change its condition. It doesn't want to change its condition. Whatever condition we are in, we like to remain in that condition only. If you try to change us, we will oppose. This is said by a body. Understand? Okay. By the way, if I tell you that if Wednesday there is 5-chapter exam, this 5-chapter exam is there on Friday. Okay? You all will oppose. Sir, how will we study within 2 days? Pay attention. How will we study within 2 days? Okay. Other batch to have told jokingly, and they all came on me. Sir, no sir, this bio exam, that exam, this exam. Okay, how many exams will we give? What had happened? I had tried to change your condition. What happened? Opposition came. This is called as what? Inertia. We don't like to change our condition. If you try to change our condition, we will oppose. He is also telling you, I am in rest condition. If you try to change me, I will oppose. If I am in uniform motion condition. If you try to change me, I will oppose. Don't try to change my condition. I like this condition very much. I am adjusted with this condition. If you try to change me, I will oppose. And who will change its condition? Unbalanced external force. If I tell you, कि भाई, if you don't give the test on Wednesday, I will all suspend you all. Then सबको देना पड़ेगा. Okay? Understand? Why? Because I am applying unbalanced external force. First I told you your test is there. I tried to change your condition. You opposed. That is inertia from your side. Then I want to change your condition, so I apply what? Unbalanced external force. If I tell you, भाई जिसको देना है दो, नहीं देना है मत दो, no one will give. Understand? But if I apply an external force, then everyone has to do that thing. Understand? Getting it? Like demonetization happened, force happened. Okay? If I would have left it by जिसके पास है, you give it, नहीं है तो मत दो. No one would have given. But when the force was applied, everyone had to deposit the money. This is unbalanced external force. When you try to change the condition, opposition will come. And for suppressing that opposition, you have to apply what? Unbalanced external force. One more example I'll give you. Okay, it happens with all the students generally. If you get up in the morning, okay, for lecture at 7 o'clock, your parents try to wake you up in the 7 o'clock. There's a lot of opposition. No, I don't want to get up. Okay? Because we are chatting 2 o'clock under the blanket. Understand? So now, if our parents try to wake us up, opposition happens. Why? I don't want to go today. If they agree, then it becomes balanced force. But if it becomes unbalanced force, then you have to get up anyhow. This is called as law of inertia. It is applicable with everyone, whether it is living body or non-living body. It will oppose inertia in some other method. You will show inertia in some other method. His inertia is his mass. Greater the mass, greater the opposition. Lesser the mass, lesser the opposition. So he is showing inertia of motion in the form of mass. You show inertia in some other form. There are many forms of inertia which the body shows while going in motion. This is first law. Did you understand? Inertia is also of 3 types. Inertia of rest, inertia of motion, inertia of direction. You must have studied in lower classes. I don't want to discuss that. Now, second law. Pay attention. अच्छा, पहला लॉ जो था, फर्स्ट लॉ, it defines the quality of force. Force क्या करता है? It changes the state of rest, or changes state of motion, or changes the state of direction. What does force do? Quality of force. Second law defines the quantity of force. How much is the force? Now we define force over here as, force is defined as, okay, or we can say force is proportional to the rate of change of momentum and takes place in the direction of force. Right now, please pay attention over here. So if a body was there, it's going with mv1. So momentum is mv1. Momentum is what? Mass into velocity. Then suppose momentum becomes mv2. To make this v1 to v2, obviously there has to be an unbalanced external force applied. Means if I am going on my bike with v1 and I change it to v2, so there has to be someone to change, no? Change doesn't happen on its own. And who caused this to happen? An unbalanced external force. I applied a force on the accelerator. And was it balanced or unbalanced? It was one-sided. It was unbalanced. So can I say the force is proportional to the rate of change of momentum? Means it is final momentum minus initial momentum upon time, because it took some time. This was at time t1, this is at time t2, which is greater than t1, obviously yes. Okay, ये हुआ 9 AM पर, ये हो रहा है 9.1 AM पर. So obviously the difference will become 1. Okay, 1 minute. This is P final minus P initial. What is P final का formula? M V2 bar minus M V1 bar by time t, and it is proportional to that. Force is defined as change in momentum upon time. And if I remove the proportionality sign, a constant will come whose value is 1. Why is that 1 taken? There is another science behind taking that 1. I will explain in some other lectures. So F will become K times of P final minus P initial by time. K ka value over here is taken as what, beta? 1. So force will become P final minus P initial by time, which can also be written as M V final minus V initial by time. Can I write V final minus V initial as V minus U by T? What is V minus U by T? Acceleration. So F bar will become M into A bar. These all formulas are very, very important. Beta. F bar is P final bar minus P initial bar by time, which is MV2 bar minus V1 bar by time, which is MA bar. This formula is not always applicable. It is only applicable when the mass of the body is constant. When I go from here to here on the bike, does the mass of the bike change? Mass is same. But if I go in some object from where the mass is changing, can I apply this formula? No. Suppose there is a water tanker going. At the back of the water tanker, you know, there is a big tap. If you open the tap, the water is being drained out. Is the mass of the water tank decreasing? Yes. Can you apply F with MA? No. There is another formula which we will deal in IIT lectures. A rocket is going up, you know. How do you launch a rocket? The fuel burns and burns and burns, and the rocket is becoming lighter and lighter and lighter. Can you apply F with MA? No. Because there is rate of change of mass. Here there is rate of change of velocity, no? Velocity is changing. Over there who is changing? Mass is changing. So there is another formula which I will tell you the tricks how to apply. Right now we are dealing with basic concepts. F with MA. F is okay, P final minus P initial by time. Which is the most important formula? Can anyone tell me? The most important formula is the first formula. Not F with MA. F with MA is the application formula. F bar is P final bar minus P initial bar by time. P final bar minus P initial bar by time. Force is proportional to the rate of change of momentum and takes place in the direction of the force. Did you understand? Now, listen to me. Third concept, third law. For every action, there is equal and opposite reaction. Don't talk. Every action there is an equal and opposite reaction. It's not so easy to analyze this law. Okay, I'll ask you some set of questions by which we can see have you understood really the force, the law. Suppose this is the table. Correct? Book is kept on the table. Right now? Or whatever. Okay, take it. It's okay. Box is kept on the table, book is kept on the table. He is pressing the table. The table is also pressing it in the upward direction. So can I say one force is applied on the table? Force on the table by the book. Force on the book by the table. For every action, there is an equal and opposite reaction. Equal and opposite reaction. Okay? Can I write this as FTB bar is minus of FBT bar because they are negative vectors? Two vectors having the same magnitude but opposite direction. They are negative vectors, right or not? Means if this is A bar, this has to be minus A bar, because as according to the definition, for every action there is an equal and opposite reaction. Means if you are applying 10 Newton, he will also give 10 Newton. Every action has an equal and opposite reaction. Okay, this you all understood, no problem. But my question starts now. Will these two forces cancel? क्या FTB बार and FBT बार कैंसिल हो जाएगा? Okay. Will they cancel? Yes. Most of the students are saying yes. Anyone? Yes, no.
Only if the body is in rest, then only they will cancel. If it's in motion, then it will not cancel.
They will do that rest. Is it rest? This condition only I am asking you.
Cancel.
They will cancel out each other. They will not cancel out each other. Listen, why? I'll give you all your answers now. This is what I am telling you, it is third law. They will not cancel out each other because they are acting on two different bodies. FTB is acting on the table. FBT is acting on the book. How can they cancel? They are acting on two different bodies. One force is acting on him, other force is acting on me. How will they cancel? Force on the same body will cancel. Did you understand? What did I say? I am pushing the wall. The wall is also pushing me. Will they cancel? No. I am pushing by 100 Newton. He is also applying 100 Newton. They will not cancel. Because they are acting on what? Two different bodies. Now you will tell me, sir, ये body rest पर कैसे है फिर? That question will come to your mind. First you got this clear. They will not cancel. They form an action-reaction pair. इसको क्या कहते हैं? Action reaction pair. Action reaction pair. They will not cancel. Action reaction pair plays a very very important role in nature. Gravitation chapter, circular motion chapter, बहुत सारे chapters में action reaction pair का play will come. Some teacher comes and confused, sir ये तो cancel हो गया. हाँ, you will say हाँ cancel हो गया. Okay, no problem. If they cancel, the net force will become zero, beta. They will not cancel. They form an action-reaction pair because they are acting on two different bodies. The game was of action-reaction pair. एंड इसी के बेसिस पर कूलम्स लॉ, ग्रेविटेशन लॉ सब बनता है. The force acting on sun due to the earth and the force acting on earth due to the sun, will they cancel? Arey, if they cancel, how will the earth revolve? The force acting on Jupiter by the sun and the force acting on sun by the Jupiter, will they cancel? No. If they cancel, how will Jupiter revolve? Understand? Net force 0 hai, so it will stand over there only. They are revolving, means they are forming an action reaction pair. I'll open all that boxes when the chapter will come. A long way to go. Okay? 2 days you attend lecture, you want to know everything, is not possible. Now, आगे बढ़ते हैं हम लोग. Your question, how they are at rest? हम लोग एक काम करते हैं, we are imaginarily removing the book outside. Imaginarily, hypothetically, I remove the book outside. दिमाग में. Really, I cannot remove the book outside. Imaginarily, I'll remove the book outside. Suppose the book is outside. Okay? What is acting on him? Which force is acting on him? FBT. Look now. FTB is to acting on the table now. What is the force only acting on him? FBT. And what is the force acted by him? No. There is another force acted by him, which is his weight. Can I say they both will cancel? Understand what's happening? The weight of him is balanced by FBT. And can I say over here the net force has become what, beta? 0. Hence he is at rest. Finished. Do you understand? This diagram is termed as free body diagram. क्या कहते हैं इसको? Free. I'll take one full lecture on free body diagram. Don't worry. Different bodies का free body diagram. Free the body from the diagram. Free the body from the diagram. I'll tell you how to do free body diagram. अभी just I have given you the trailer. FBD. It's called as FBD. Free body diagram. Correct. Every action has an equal and opposite reaction. One more example. Horse cart problem. You've seen horse cart at Nariman Point, right? Horse pulls the cart with 1000 Newton. The cart also pulls the horse with 1000 Newton. How does the horse move forward then? Yes, you know the answer. The horse borrows the force from where? From the ground. How is that happening? Please pay attention. That happens by the horse pushes the leg in this direction. Yes or no? Like this. I'm not showing you the whole diagram. I don't know how to make horse also. ऐसे the reactionary force by the ground will be this way, beta. Can I say let this make an angle theta? Can I say this component will become R cos theta and this component will become R? Perfect. Can I say R sin theta is balancing the weight of the horse and R cos theta is unbalanced, which is responsible to push the cart or pull the cart forward. Please try to understand. The weight of the horse is balanced by R sin theta component. The R cos theta component is a pull which is unbalanced, which is responsible in pulling the cart. Did you understand? This is called as horse cart problem. This is there in NCERT also. समझ में आ रहा है? This is action reaction. And many questions of free body diagram, they all are done by Newton's third law. This is action reaction pair. Rather than drawing free body diagram of the book, you want to draw free body diagram of the table. No problem. This is the table. Right, na? Imaginarily you remove the table, not the book. Now we know the book is applying which force? FTB. Where is the weight of the table also acting? Down. They both are where? Downward. We know this and one more is there, okay, on the ground. Can I say the ground will provide a reactionary force? How many R's will be there? 4. Can I say this 4 are upward? 4 R upward will balance FTB plus W downward. How much is the net force, beta? 0. And the table is also at rest. I told you I'll take one full lecture on free body diagram. This is nothing. Okay, complicated free body diagrams we'll try to make. And it is a trick how to follow free body diagram. I'll give you all the trick at that moment. Clear ho gaya? Now, we are studying impulse, denoted by the letter J bar. It's denomination for every term. J bar vector. Impulse is defined as large force acting on a body for a short time. If there is no short time, if there is long time, then also no problem, you can apply the formula. J bar will be average force into time taken. Sir, why average force? Force into time, it is not. Why average force? Suppose if I hammer a nail in the wall. I hammer a nail in the wall. When I hit it, at that moment only the force is maximum. When it pierces and goes inside and inside and inside, the magnitude of the force becomes lesser and lesser if you go in slow motion. When I hit, okay, the force will, what will happen? First it is maximum, then when it goes inside, it will become lesser and lesser. So rather than taking a force which is constant, it is a variable force, na beta? Therefore we have taken average force. Because initially it was maximum, then it became minimum. So I'll consider F1 plus F2 by 2, na? Into time taken. A batsman hits the ball. At the start, when the ball touches, it is maximum. But if you see in slow motion, when the ball is leaving, the force becomes 0. Once it is left the bat, how much is the force acting on the ball now? 0. So initially it was maximum. Then it became lesser and lesser and lesser. Go in slow motion, then it will become 0. So what force? Is the force constant? No, it is a variable force. Hence you consider average force. Have you pressed a spring? Yes, 2 Newton, 4 Newton, 8 Newton, 10 Newton. Is it constant force? Can I press it with 2 Newton only? No, it will come at a certain stand and point and will stand over there. 2, 4, 6 is variable force. So here also there is variable force. Yahan par bhi there is variable force. Therefore the average force comes into consideration over here. Into time. Can I say what is the formula for force? Can I say it is final momentum minus initial momentum upon time? Time and time will cancel. So average impulse will also be written as P final minus P initial. So there are 2 formulas for impulse. One is average force into time, and second one is P final bar minus P initial bar. This is very important. Now I'll do applications of impulse better. Can I say impulse is force into time? So can I say average force will be impulse upon time? Hey, look na. Suppose if I take impulse as a constant, so can I say average force is inverse to time. Means as the time increases, average force will decrease. As the time decreases, average force will increase. Now there are very beautiful examples in nature of this thing. Impulse is constant. Force is inverse to time. I hammer the nail in the wall. Okay. I want to hammer a nail in the wall. If I stand like this for 1 hour, will it go inside? I stand like this pressing. No. What did I do? I increased the time. The force has decreased. What do? I take a hammer and just bang it for a certain moment of time. I have decreased the time, so the force will increase, and because of that force it will pierce the wall and go inside. By standing like this for 1 hour, nothing will happen because the time has increased. Okay? Getting it? You slap someone. When you slap someone, okay, the contact with, okay, is very small, no? The contact with the body is very, very small. If I do like this, then it will not hurt because you have increased the time. So the force come magnitude has become less. These are all daily examples, man. Another example. You jump from a high-rise building. So today all blue whale and everything has come, right? So now jump from a high-rise building on a cemented floor. Can I say the time of contact with the cemented floor is very small? When the time is very small, the force will be very high, which can cause maximum damage. But if you jump on the from the same high-rise building on a sponge, which is 2 floors high, so can I say the time taken to decrease the speed gradually becomes less? The time taken has become more, no? To become 0. First it will become V1, then V2, then V3, then V4, then 0. So what has happened? I had increased the time. So the average force will decrease. So you will not get so much hurt. When you do bungee jumping, the rope which is tied to your body is a nylon rope generally, which is extensible. Why? Because when you come down, it will extend, it will increase the time. So the force will become less. But if I have an inextensible rope, it will break your back. At one moment it is stopping. So it will decrease the time and the force will be very large, which can break your back only. You understand? An athlete runs 100 meters and after finishing the race, he also runs. So why are you running now? He increases the time of stopping so that force acting on the body becomes less. He will not fall down. Suddenly if he stops, he will fall down due to inertia, because he is in inertia of motion. Understand? And gradually it should stop. Glassware material, okay, fragile glassware material, they are all packed in thermocols. Why? Okay, because if the time of contact becomes very less, they will crack. Thermocol is placed. Thermocol will act like a sponge, which will increase the time of contact and the force will reduce. They will not crack. Are you understanding? Okay. So this is all about impulse. If you decrease the time, the force will increase. If you increase the time, the force will decrease, and vice versa. Impulse is going to remain constant because one is more, other is less. One is less, other is more. 3 into 2 is also 6 and 2 into 3 is also 6. So 6 is constant, na? I am trying to tell you that. Try to understand. 2 into 3 is 6. 3 into 2 is also 6. Impulse is, that's why, constant. Force can become less or more according to the time taken. You get it? One more example. Shock absorbers are placed in bikes, cars, bicycles. Why? Because whenever a pothole comes, okay, the shock which is reaching your body will take more time, and the force of that shock will reduce. Getting it? Buffers also placed in trains between the bogies. Okay, same concept as that, to reduce the action of the force. We'll continue with law of conservation of linear momentum next time.